So hey guys, in this video I want to talk to you a little bit about my experiences with live streaming, ultra low latency live streaming, using OBS Ninja, making professional productions, some of the pitfalls, some of the things you have to be careful of, how to prepare for a live stream, or at least how I prepare for a live stream. It's an ever-evolving process for me. Some of the tools I use, some of the tools I've made, and just giving you some fair warnings on some of the pitfalls you need to be aware of. Okay, so as a background, I have been live streaming with WebRTC, which is the technology OBS Ninja uses, for over 4 or 5 years now, 5 years, I'd say. And it's a lot easier today than it was even a year ago. That said, there's still many things that can go wrong. You can prepare as much as you think you needed to prepare for a show. You might think everything's working great, and you go live at 8:01, and at 8:02, things are a complete mess. And you might have been planning all day for this live stream, and you're wondering why things have suddenly went south right when you started live streaming. It's like Murphy's Law, right? And you feel like the world's against you, but the reality often is, at 8:02, 10,000 other people in the area have the same idea as you to go live. It's prime time, right? Everyone wants to go live at the same time because that's when all the eyeballs are on the TV. So you can't test during the day and expect the results to be the same at prime time. So if you're going to do a live stream, it's better to do it outside prime hours. If you are concerned about packet loss, if you're concerned about reliability of the stream, and if you are going to go live at prime time, do a few days of testing at the same time you intend to go live, right? Don't test during the day and expect things to be the same at night. Comcast, Cox, these American IPs, ISPs, they suffer from a lot of problems right now, especially with COVID, where everyone's trying to use the internet and their system just is falling apart. Even if you aren't on those networks, the internet as a whole is a public destination. Your traffic has to go through the public internet. So if you're talking to a peer somewhere else in the world, it doesn't matter if your internet's good. It's really dependent on whether your connection to their connection through the public internet, whether that is good. It could be good 99% of the time, but it could go really bad 1% of the time as well. So depending on what sort of quality you're looking for from a live stream, are you comfortable with moments of it degrading? Because if so, you can't just test for 5 minutes and expect it to last a full hour. So setting some expectations here. Low latency live streaming, where you're pulling remote guests into like OBS, for example, using OBS Ninja, isn't the same as traditional just publishing from OBS to YouTube. There's a fundamental difference in the technology. When you're publishing to YouTube, you're publishing over RTMP, which has like a 2-second buffer, 10-second buffer on the video. So when you're sending the video to YouTube, if any of the data gets lost, the connection has a chance to recover, to resend the data, to make sure everything's being sent. And if it doesn't, it will kind of just buffer until it is all there. With WebRTC, it waits for no one. It waits for maybe like 30, 40 milliseconds. And then it's like, I'm done. I'm just going to keep moving forward because it's ultra low latency. You cannot wait for the data to resend sometimes. It will try to adapt. So the quality of the video might go really low quality, trying to minimize the amount of data it needs to send if the connection is bad. But it generally will not wait around to resend the data. So you'll have massive frame loss. You'll have audio clicking. You'll have sometimes corrupted video frames, depending on which browser you're using. all these issues are going to be caused by a bad connection. So when we're talking about low latency video, probably the most important thing is to ensure the connection between all the participants is as near flawless as you can get it. If you can do that, you'll have an exceptional. I think you'll have a pretty good experience. Most of the other issues you'll run into will be things like echo cancellation, people not wearing headphones, or often when you go live with any live stream, you want to go live at 8 o'clock sharp. People aren't ready. You end up going live at 8:20, and your guests are waiting. All these things need to be accounted for. But if you can just make sure the connection is solid ahead of time, and that often means putting in some work. And it might mean getting your participants to do work, or it might mean sending someone out to the performer's location to set them up with a technical expert. These are all things you really need to consider and actually do if you want a professional live stream. It's very rare you can just go live and expect it to just work. So that's the first thing I'd say is prep for these things. Don't expect them to just go off without a hitch. Test during the hours you expect to live stream. If you're live streaming at 8, test a few nights a week at 8 p.m. Don't test at 2 p.m. in the afternoon, because it's not going to be the same experience as you going live at prime time. Everyone wants to go live at prime time hour, and that's when the connections are going to be the worst. The internet, especially in the US, doesn't handle peak hours that well. Okay, so the first thing I'm going to do is I want to load up OBS Ninja here, and we'll just click on that little button, and we see that we have a run speed test. One thing that start virtual camera. Okay. So we have a virtual camera set up here. One thing to be aware of when we are doing any sort of speed test is that, let me put my camera back for a second. We often do a speed test like at speedtest.net or something like that. That's not a packet loss test. That's not a connection quality test. That's just testing your maximum up and down. And it really has very little relationship to what we actually need to test. So I don't care if your connection is 100 megabits up or down. It does not matter. It doesn't. As long as you have like 3 or 4 megabits up or down, you have enough to live stream. What matters is the connection quality. Okay? Quality. And so this particular speed test I have here, here is, we're going to start it. We see that we have the video going in and the video coming out. I'm using just the virtual cam output from OBS here. Anyways, my camera is in use. So the idea here, though, is we have packet loss, buffer delay, and bit rate. And packet loss is important. This shows us how many packets we're missing. So how much data is being lost when we're transmitting video from point A to point B. And in the ideal world, you want 0 packet loss, 0%. I'm going to open up a program called Clumsy, which is a simulator for packet loss. Let's see if I can get it working. And we are going to do a UDP packet loss drop. I'm going to drop 1% of the packets, or roughly 1%. Okay, well, we're going to see what happens when we start dropping packets. Start. There we go. Okay, so we're dropping packets now. We'll see what happens. Packet loss is increasing. 0.2%. 0.3%. You can see in the bottom right, there's a graph, right? And it's slowly increasing. So we're dropping about 1% of the packets. And things are pretty okay. We'll first see that the buffer delay jumped when we started increasing these packet losses. And the system is intelligent. It will try to increase the buffer if it sees there's packet loss. And it will then try to adjust things so that it's not too impactful. Let's go with the higher bit right here. Probably won't do anything actually. Next, I'm going to add throttling. So this is going to be pretty impactful. Chance of throttled packets, 10%. Okay. When we did throttling, the delay went up quite a bit. So this is introducing like a delay to the video. And then we're going to add some lag. And now we're starting to approach what you might see with a bad connection. So you're going to be seeing higher buffer delay. The system is trying to compensate for the bad connection by increasing the delay of the video. And the packet loss is representing the number of packets we're missing. And as our packet loss goes up, the system is going to scale back the bit rate. It's not going to be hitting the high video quality that we're used to. It's going to scale that back, okay? And as you see, as the packet loss slowly increases here, the system is starting to get more and more aggressive with the buffering delay. So the video is going to slow down. You're going to start getting audio and video synchronization issues. Audio does not slow down with WebRTC. It always tries to play as fast as possible. But the video will slow down. So you might get some lip syncing problems. The quality of the video will start to drop as you start getting packet loss problems because it won't be able to send the packets reliably. And I'm going to stop this. So I stopped the packet loss, and we should see that things should start to recover in a few moments. It doesn't recover instantly, right? And packet loss comes and goes in waves. So you might see people talking normally for 20 minutes, and then for like 2 minutes, you might see their lips follow to sync. And it looks a little bit odd. And that's largely because they had a moment of heavy packet loss. Maybe someone put a microwave on. You're going to have problems where the unexpected happens. And it's a very gradual recovery. The system does recover cautiously, but this is eventually going to recover to where we started with higher bit rates, lower latency, and ultimately better quality. Okay, so this is a visualization of how you can use this tool. My recommendation is you want to get packet loss around 0.1% or lower. If you get at 0.3, you're doing okay. But if you're hitting 1% packet loss, you're not ready for a quality production. It's more of a casual quality. And if you're getting 2 or 3% packet loss, I'd say you're not really ready at all to do live video. 2 or 3% is going to be a poor experience. Lower quality video, it's going to look more like you're in some sort of crummy Zoom call or something like that. It might be passable, but not to the standards that I would suggest. Now this tool, the way it works is it finds a server. I host several servers online throughout the world, finds the closest server, and it sends the video to your server, to the server, and then back to you. And in this way, you can test on your own whether your connection quality is good or not. If you want to test with the peer and not with this test, we can open up OBS Ninja. We can, let's say, create a link. And when we share this link with our guest, we're now capturing their video. So let's say this is the guest. We send the link to them. As a viewer of the stream, we can hold down Control and click on the video. Left click. Okay? I'm going to stop the virtual camera. It's annoying me. So here we go. And we get the stats page. And we can see all these interesting stats. We can see that the remote connection is on an Ethernet connection, which is, so I'm on Ethernet. We can see that I'm on Windows. We can see the audio bitrate, packet loss for audio, the delay. So there's 20 milliseconds of delay in the audio, which is really rather low. We can see which codecs, what resolution, the buffer delay of the video. You see how the video has a 35 millisecond delay while the audio is 20 millisecond. That's normal. Frame rate 29. These are things we can look at. Generally, the one I would recommend is looking at packet loss right here. And leave this run for a few minutes and just monitor the packet loss when you're engaging your guest. See if the packet loss is staying under 0.3%. If you can get it down to 0, perfect. 0.0001 is also pretty okay. And yeah, if it's not pristine, if you're dealing with like 1%, 2% packet loss, you need to start troubleshooting. Okay. I'm going to stop the screen for a second. So how do we troubleshoot? Well, so there's some common things we need to look at. First of all, we need to make sure no one is on Wi-Fi. Wi-Fi will introduce anywhere between 0.1 and like 3% packet loss. When you're sending data through the air, right? Not all of it's going to get to the other antenna. So Wi-Fi is a no-go. Do not use Wi-Fi for a live stream. Someone turns on a microwave next door, you're going to have a sudden 3-minute spike where you have no, good internet. And you have no control over that, and you can't really predict for it. So don't use Wi-Fi. Like, invest in a 300-foot Ethernet cable if you need to. Your guests aren't going to like you for this. If you're bringing a remote guest on, you say, use Ethernet, they're going to be like, well, that's so inconvenient. That's in the other room, or I don't have a cable long enough. It's the difference between a show that goes well and a show that goes really bad. Okay. So, if you're using a MacBook, you're going to have to buy an Ethernet adapter. When I have a Mac here, I have an Ethernet adapter, it plugs into the USB port, and then I hook up the USB dongle to an Ethernet cable. I have to do that. You cannot rely on Wi-Fi. Other things you can do is make sure the laptop, if you're using a laptop, make sure it's plugged into the power outlet. If you're running on battery power, the system's going to run on low power mode, and that's going to reduce the CPU performance. It's going to reduce the power usage for maybe antennas or for whatever. For all intents and purposes, always try to use, plugged in laptops, or if you can, a desktop. If you're dealing with low frame rates, it may not be the video quality. You may just need to, turn on your lights. So if you're dealing with low frame rates, 10, 15 frame rate, sometimes just turning the lights on will solve that problem. Next, we're going to talk about what happens if you are on Ethernet and you're still having bad packet loss? Well, as I mentioned, avoiding prime time hours is a good idea. Don't go live at 5 to 9 p.m. Somewhere in between there is prime time. Try to do it earlier in the day or very late at night. You'll have a lot better results. If you are fortunate enough to have something like a decent data plan, LTE 4G data or 5G is good stuff. You generally will get 0.3% packet loss or lower when you're using LTE. You might get some frame loss, but there's something we can do about that. So one thing you can do is you can plug your phone in, put it into a USB tethering mode, and plug that into your laptop. If your Wi-Fi or your Ethernet is really bad, plug your phone in, use the data. You'll get a much better quality connection, like 0.3% packet loss versus 3%. Pretty substantial. If you can also do something called bonding. So here's an application, Speedify, and it's clumsy. I'll close that. There we go. So we have Ethernet listed here. What I can do is I can take my phone. I can go into settings, turn on my hotspot, go in and then hit USB tether. An iPhone or an Android will have this. And in Speedify, we see that we now have Ethernet and cellular listed as a connection. Speedify is free to try, 2 gigabytes a month, a free bandwidth. You can buy it for like a few bucks a month. It's pretty cheap. And what it does is it will bond your connection. So it will send essentially 2 streams of the video, one over Ethernet, one over cellular, send it to a server, and that server will take the best packets from both connections and forward that to your peer. So it's like a fail-safe redundancy option. When we plug in Speedify, we see that we have Ethernet and cellular listed. It knows it's my phone, but it sets the cellular as secondary. So what we're going to do is we're going to turn on Speedify, and we are going to change this to primary. Okay. Boom. So now we have cellular and Ethernet both as primary. We don't want cellular as secondary because then it's not going to use it. The next thing we're going to do is we want to go up here to the settings. We want to choose bonding mode at the bottom. It says session type, streaming, or bonding. We're going to set it to redundant. Okay, so it will explain what redundant mode is here, but we're essentially sending the traffic over both connections to the server, and yeah, you can manually select where you want to go to. But now we're essentially sending video to both the cellular connection and our either Ethernet or Wi-Fi connection via Speedify, and Speedify will now help us reduce our packet loss. It's a pretty cheap service. The main cost of this approach is your data on your phone plan. You're spending like $40 worth of data perhaps for some live streams, but it's worth it, right? Having a reliable live stream, especially from a production capacity, a professional capacity, is very important that you make that investment. If you are very serious, you can forego Speedify and go with a more expensive hardware bonding solution. So there's hardware devices that will have better quality antennas, multiple SIM card support. Those might be $800 you can look into, and they might offer better quality, lower packet loss, 0.1 and less. I guess you could kind of achieve with those, but they are expensive, right? If you have a remote performer, you can send them a little kit that has like maybe a hotspot with a prepaid SIM card in it, or you can send someone out and they can go to a Best Buy, pick up a USB-based 4G hotspot, or you can just use a phone. If you have a phone, it's a little bit trickier. If someone calls, if the phone goes into some sort of power saving mode. During this live stream, this phone actually restarted to apply an update. And those are things you don't really expect. So while you could use your phone, I personally invest in a USB hotspot, and I'll connect that to the computer. If you do have a USB hotspot, try to get one that has an Ethernet output port. And if you can, connect the hotspot over Ethernet to the laptop instead of USB. While USB, it will work. Some USB ports on computers and drivers don't work that well. They might have buffer bloat or some sort of conflict. So if you connect it over an Ethernet port, you kind of circumvent those potential problems. It's unlikely you'll run into that, but it's actually occurred a couple times this year for me where the USB port was not really stable on someone's computer, and using a Ethernet port solved the problem. So again, all these little things that you need to take into consideration when doing a live stream. Okay, I'm going to turn off Speedify since I don't need it on, and okay, what's next? Okay, let me go open up OBS Ninja again, and we'll talk more about things here. As a publisher, as a performer, you have options here as well. Something called a send keyframe. And if you press that, it's going to reissue your keyframe. Why I mention that? You also actually have this option here. If you go into the director's room and you invite someone, I'll show you that there's an option there for the director. The director also has this button now called Rainbow Puke. And if you press it, it's going to issue a keyframe as well. You can ignore that. Okay, so when you're using OBS on PC uses an older version of Chromium. And when you have high packet loss, Chromium will create a corrupted frame. So you'll get essentially like this pixelated puke effect. It's going to look like rainbows and smearing and looks like ugly. If you issue a new keyframe, it will clear the picture up. Keyframes don't get sent very often with WebRTC. They only get sent when they're needed. And with OBS, there's a little bit of a glitch where it doesn't know how to request a keyframe correctly, it seems. So you can manually force one and it will fix the picture if you run into that problem. It should not occur if you are using Ethernet with a good quality connection. You shouldn't have packet loss in the first place, so you're not going to have those problems. But if you are using OBS and you have some corrupted pictures, you can use those buttons to send a new keyframe. You can also just refresh the browser tab in OBS, and that will also clean the picture up. If things still remain really bad, what you can do is we can go to the Electron Capture app. I host it on my GitHub, Electron Capture. We can go to the release section and we can download it for Mac or Windows. Mac users don't really need it, but for Windows, you can download that. And when we use that, it essentially is a frameless version of the browser, a frameless version of Chrome. Makes it very easy to window capture. And so you play the OBS Ninja video in the Electron Capture app, you capture the frameless window into OBS, and you got yourself video that way. It's an extra step, but it's going to be more reliable than OBS if you have heavy packet loss. The Mac version of OBS doesn't have that problem. It's using a newer version of Chromium. And with any luck in the next few weeks or months, the PC version of OBS will have the updated Chromium build. vMix also doesn't have the problem. So it's really just a problem for the current version of Windows OBS. It shouldn't be a problem for much longer, but something to consider. What else? You can change codecs, H.264, things like that. They might work better. If a CPU is overloaded on the performer's end, if they're trying to push too high a resolution or there's too many people on the computer, it's going to cause the audio perhaps to desynchronize from the video, maybe by even 1 to 5 seconds. So in that case, you need to be aware of that. Try to reduce the CPU load on these remote guests. I would strongly recommend you don't try to stress out any remote performer who has a 2015 MacBook. If they have like a 2012 MacBook Air, that's a no-go. They should not be going live on air. 2015 MacBook, you just have to make sure you're really careful around those users because those laptops might be full of dust. And over the course of an hour of live streaming, their computers are going to overheat. And like an hour into the live stream, their frame rate's going to plummet and their quality of the video is going to plummet because their CPU started to thermal throttle. Try to bring in performers who have more modern computers, quad cores, good cooling, preferably not laptops, and you should be good to avoid those problems. I think that's a good chunk of information for now. The general theme is you want to reduce packet loss, and you want to take testing seriously. You want to test at the right times. You want to set up with the right prep, have the right tools in place. If you do that, your stream has a much better chance of succeeding. If you do no prep at all and you just wing it, there's a very good chance the stream is going to end up being dog poo. Okay, so it's not simple. It really does require prep, tinkering, and you can always join the Discord forum, discord.obs.ninja. I'm on there, live chat. If you have problems, talk to the community, ask for ideas. We're here to help. A week before the live stream, get on, start talking, start experimenting, get your performers to go on Ethernet, get them to test with you. You'll be rewarded if you do that. Okay. Thank you so much, guys. I hope that made sense.